Hey there everybody, I guess I'm back with another video on Hires Webassign. Today I'm going to be covering question number 17, which most likely is the hardest question on the Webassign since you don't learn a specific formula for it and you have to derive it. Anyway, so we'll be starting on number 17. So here we have a basic diagram of the trajectory of the water. And to solve this question, it kind of goes back to the fruitful Webassign. You kind of have to use a system of equations. So first of all, you have to separate the x and the y components. So here's what you do know. You know basically the total displacement in the y direction from the water. In my case, it's 1.4 meters in the negative direction, and you also know the displacement in the x direction. In my case, it's 3.8. And you do know the angle of launch, but nothing else. So what we're trying to find is the initial velocity. Well, technically the speed, direction doesn't matter. And here I'm going to denote the original speed as x. Just don't get that confused with anything else. So on the x side, first we have to solve for x as a function of time. So here we have this 3.8 equals x cosine 27 times t, because distance equals speed times time. Here there's no acceleration, so we can use this very simple function. And we can isolate out the x by dividing the 3.8 by cosine 27 times t. And you can calculate cosine 27 on your calculator, and you'll get that x equals approximately 4.2648 over t meters per second. Now, this is where you start. That was annoying. Alright, now we have to go into the y direction. For the y direction, you know that using the second kinematic function, that delta y equals v naught t times 1/2 t times 1/2 a t squared. Ooh, I wrote that wrong. Anyway, now you can substitute things in. You know delta y is negative 1.4 meters, or whatever number you have. I suppose it won't be the same thing, but negative 1.4 would equal x sine 27t minus 4.9 t squared. Now, here's the thing. You do not know x, as you have not found out x yet. But now you can. But you have figured out a function of x you figured out x as a function of time in the previous part of the question. So you can plug that in for x, therefore eliminating the variable and making the only variable in this function time. You just basically plug in 4.2648 over t for x here. You'll get this. Now it's very convenient that the two t's here will cancel out because one's in the numerator and one's in the denominator. So basically you would get negative 1.4 equals 4.268 times sine of 27 minus 4.9 t squared. Simplify everything out. You get negative 1.4 equals 1.94 minus 2.9 t squared. From here you can just basically solve the quadratic. Easiest way is probably to take the square root of both sides. That is supposed to be 4.9, that's my bad. Either way, you'll get that time is approximately 0.825 seconds, and then you have to go all the way back to the top. Probably the easiest way is to go all the way back to the top and find this initial function of your first function of initial speed as a function of time. And then you plug in the time you found into that function, as shown here, and you should get the initial speed. Alright, so if you have any questions, feel free to tell me. And I'm sorry I couldn't do the rest of the Webassign, I'm a little short on time. But it seems the rest of the Webassign questions can be done using the range equation, or yeah, it's not too difficult from here out. Alright, thanks for watching. Goodbye.